Hello everyone, I'm Ku-Chieh. You can call me Kyo. I appreciate to get an opportunity to give presentation in HackinBox 2020. Today I will present a continuous journey for manufacturers to develop cyber-resilient IoT devices. In this session, I introduce the continuous work, how we as a manufacturer to make our IoT devices resilient against cyber attack. Before I start the session, please allow me to introduce myself briefly. I am an IoT cybersecurity analyst in the Panasonic Cybersecurity Lab, and I focus on analyzing IoT cyber threat and improving IoT product security of Panasonic. I was a group leader of the Cyber War project in NCIST and was also a training instructor of cyber attack for Ministry of National Defense in Taiwan. In the past 3 years, I was a cybersecurity researcher focusing on cyber threat hunting and developing cyber threat defense solutions and NSGAR technology. At the same time, I was also a cyber incident response training instructor and supported to the cyber incident response for Criminal Investigation Bureau in Taiwan. Please feel free to contact me via email if you have any question about this talk. There are 2 topics in today's talk. In the first topic, I will briefly introduce current Panasonic doing like product security research, product security activities, and the threat intelligence project. In the second part, I will introduce the continuous journey, what manufacturers should be keep working on the product security. Let me introduce the background of IoT product security we observed. The number of cyber attacks has increased year by year. In 2018, over 20,000 billion attack packets were observed on the Internet. Moreover, about half of these observed attacks target IoT devices, such as web camera or routers. What this means is that IoT devices are being targeted by attackers, in addition to traditional information systems. This is due to the booming development of IoT industry. In addition, Kaspersky also counts the number of IoT malware collected from 2016 to 2018. We can observe a substantial increase from 2017 to 2018. The number of IoT malware has more than tripled from 2017 in just the first half of 2018. It was notable IoT malware Milai, discovered in September 2016. Since then, the number of IoT malware has suddenly increased. So besides some of these scary numbers, various articles have been published in the media related to IoT malware and the types of attacks they are causing. Some articles provide more details than others about the attack or techniques used by attackers to infect a large number of devices. And we as a manufacturer want to ensure that our products do not become infected. If our company name appears in any articles, not only is this a technical risk in that our products are vulnerable, but it also becomes a reputational risk in that the general public will know that our products are vulnerable. Thus, it's important for us to understand the threat landscape in regards to IoT devices and proactively protect our product from such attackers. This is a sample for infect IoT malware and the attack process. In the first step, some IoT devices are infected by malware, which hacker sends by vulnerability. Next, the infected device will separate the malware automatically to other IoT devices, which have the same vulnerability. This infected device will become a botnet, and hackers use the botnet to carry out DDoS attacks. Most important thing is victims are now turned into attackers, but they don't know what happened in their IoT device. Therefore, users should not consider that there is no sensitive data on their IoT device and do not need cybersecurity over the IoT product. They will break the law after becoming an actor. As this rate has continued to increase, various governments across the globe have become active in creating regulations to secure IoT. This slide lists some of the regulations related to securing IoT devices. In the United States, there are some federal laws as well as some state laws to govern IoT security. In Europe, the EU has put out some regulations, which each of its member states are implementing. And China has a nationwide cybersecurity law to govern the entire country, while Japan has issued some regulation as well. So with all that was just said, how can we as a manufacturer take actions to protect our products and users? This graphic shows the various stakeholders that surround a manufacturer like Panasonic. The important thing to note is that cooperation with these various stakeholders is necessary to improve product security overall. One other thing that we must always keep in mind is that our customers will always expect the manufacturer to ensure security of its products. And as a manufacturer, satisfying our customers' expectations is critical to our business. In order to improve product security, not only manufacturer but also other stakeholders need to take initiative. IoT cybersecurity cannot be a complete product unless all parties are concerned about it and work about it. Next, I will introduce the Panasonic activities on product security. Cyber attacks are considered a major corporate risk at Panasonic, and preventing cyber attacks to protect company assets is critical. This chart shows the best framework for risk management at Panasonic, and it also public available on the Panasonic corporate website. To protect Panasonic from cyber attack, three main pillars have been established. The first on the left is IT security, which focusing on securing the corporate IoT infrastructure. This include the corporate network, web servers, employee PCs, and other infrastructure necessary for employees to perform day-to-day operations. This is a team commonly established within most organizations. The other two are more unique to manufacturers such as Panasonic. Skipping over to the right is factory security, which focusing on securing the factories and systems that manufacture our products. Lastly, in the middle of the image is product security, which focusing on the security of various products that are shipped from our business unit worldwide. The three teams cooperate on common issues. For example, sharing the vulnerability information and any incident response that may be necessary. And now focusing on product security. All activities for product security are to support the Panasonic brand, as it is critical to ensure that users of Panasonic products can have a peace of mind that the product is safe and secure to use. To accomplish this, there are two main activities: minimizing risk and incident response. The former is a group of activities undertaken prior to shipment, and the latter after shipment. Best for these activities is aimed to provide technical knowledge of security vulnerabilities and how to address them, as well as awareness to the development teams about current security trends. All activities for product security are designed to ensure security throughout the entire product lifecycle. The green items here are for pre-shipment, and the red items here refer to any post-shipment response. The Product Security Center at Panasonic provides support to internal developers throughout the product lifecycle. For some of the items, such as threat analysis and secure design, we provide guidelines and other supporting documents for assistance. This shows the product security incident response framework at Panasonic. The PISA cooperates with external organizations such as FIRST, security vendors, coordination centers, and academia to coordinate any reported vulnerabilities in our products. PISA has a public accessible contact where vulnerabilities can be reported by external stakeholders. Once the PISA receives the report, analysis is performed to ensure that the report is legitimate and there is enough information for developer to verify the reported vulnerability. After this is done, the PISA will distribute the report to the affected division. In order to enhance the security of product development, we provide continuous product security education and training. Education and training are mainly divided into three levels: basic, intermediate, advanced. In different Panasonic manufacturing units, we will training IoT developers. Through a series of training, each developer of a Panasonic manufacturing unit can create IoT products with fundamental security. As we just presented, Panasonic has been taking various actions to make our product secure, but challenges still exist. The response to this challenge is the reason why we start to make Panasonic IoT Threat Intelligence project. We are facing a lot of challenges in product security. Incident response requires a trigger, such as an internal or external notification of a potential issue. Sometimes it's super late to trigger notification, so we should not rely on external organization to collect threat information. We believe that by proactively collecting and analyzing the threat information by ourselves, we can utilize this information to make our product more secure. This was the concept behind the Panasonic IoT Threat Intelligence project. This is the overview of Panasonic IoT Threat Intelligence platform. This platform consists of three main parts. First one is collection. We have to deploy the honeypot to collect, attack, and malware targeting our products. Second part is analysis. We analyze the data collected by honeypot. Third part is protection. Our goal is to strengthen overall IoT security in our products by utilizing the analysis data. Next, I will provide more detail about each part. First is collection. This slide shows the current progress of the entire project. We have two types of honeypots. One is the software honeypot, and the other one is actual Panasonic IoT devices. As you can see the photo on the right, we have a showroom that displays the actual products that collect incoming threat to itself. In addition to this, as a manufacturer, we have the ability to be able to deploy products in development. This can be a big advantage because it gives us the ability to collect threat information before shipment. We can take the measures to address any newly discovered vulnerability or threats. This is an activity that was recently started. We currently have two observation points, Taiwan and Japan. In near future, we plan to increase observation points and include US, EU, India, APEC, and China. Second part is analysis. A collection of malware targeting IoT home appliances is ongoing. Recently, we have collected many malware targeting various CPU architectures. We perform behavior analysis specialized for IoT malware. Internally, we have defined IoT malware as any malware targeting the following CPU architecture: MIPS, ARM, ARC64, PPC, and SH4. Moreover, we have automated the analysis process from malware collection to statistical analysis to reduce the amount of necessary manpower. If we find any interesting behavior in a particular piece of IoT malware, we will analyze it more deeply by manual. Third part is protection. For us, this is the most important phase in our quest to make our products more secure and resilient against attacks. We have started to share both attack overviews and IoT malware analysis report to product developers this year. Our next challenge is to analyze risk against our products, including those that are under development. We plan to categorize and analyze attacks using a framework, such as MITRE, ATT, and CK. Then we will analyze any target vulnerability against our products to assess countermeasures specific to our products. Finally, we hope to provide this analysis as helpful feedback to our developers, so they can utilize this feedback to make product more secure. After introduce how we doing in the first step, let's talking about the continuous journey for manufacturers to develop. cyber reliant IoT device. This is the data statistics of an attack source IP that we collect from July to September in 2020. We can find that the top 3 source IP with the most attacks are botnet from New Zealand, and some IP we captured that have sent spam mail before. The top 5 IPs carry out more than 600,000 attacks on our device within 3 months. We could deny this is attack source IP on IoT device or cloud service which connected by IoT product after we capture them from the honeypot, so that make IoT product more secure and avoid this cyber threat. This is the statistic of a target service we collect from July to September in 2020. You can see that most of the top 20 are known and common service, and the first most frequently attacked service is Samba. Therefore, if IoT devices use Samba service, special attention must be paid. Manufacturers need to effectively guide users to avoid incorrect configurations and expose Samba service on the internet so that anyone can access them. In addition, Microsoft SQL database, MySQL database, Postgres database, Oracle, this is key database service are all in the top 20 list, and they are also the most interesting targets from hackers. In addition to statistics on attack source and the target service, we also conduct NID's detection statistic on intrusive network traffic. The most alert are malicious or poorly reputation IP source, followed by the detection of host survival scan and well-known network service such as SIP, Samba, and RPC. It is also worth noting that MySQL has been detected nearly 300,000 times from July to September. Some result is in line with our previous statistic of target service attack. For the most frequently attacked HTTP service, we also count the URL frequently accessed by hackers. The top 10 records are as below. Number 1 is scan whether the root directory exists. Number 2 is think PHP file exploit, which could find the same command on the internet. Number 3 is try to scan CVE 2020 A155 vulnerability. Number 4 is try to scan CVE 2018 106561 vulnerability. Number 5 is hardened service scan. Number 6 is reliant auto scan. Number 7 is HNAP1 exploit scan. Number 8 is Tomcat manager scan. Number 9 is command injection attack, which want to download Malware from intranet. IP address is 192.168.1.1. Number 10 is command injection attack, which want to download B3AST malware from internet. The interesting thing here is that the infected machine tried to compromise the victim and download the malware from the download site 192 and .168.1.1 IP address from intranet. We don't know if this is intentional or unintentional attack by hackers. Anyway, we need to pay attention to this intra-IP address. Let's talk about the IoT cyber threat management after get analysis result. When we use IoT device as honeypot to collect cyber threats, this data must be stored effectively. Since public attacks are numerous and frequent on the internet, it is recommended to use a powerful log collect system or architecture, such as ELK, low-stage Elasticsearch, and Kibana. This diagram is a simple storage example. Using distributed Elasticsearch for large data storage and monitoring data from Kibana. After we having a large amount of data stored in Elasticsearch, we should separate and normalize the data. Since the threat intelligence required by each manufacturer is different, we must filter this intelligence information and store it by a common format. For example, a manufacturer that develops IP cameras, they will concern about the cyber threat of RTSP protocol attack. Another NAS device manufacturer that use same remote terminal service will concern about sandbox or telnet attacks. After the data is filtered and stored, a large amount of the raw data can be erased to avoid ever-increasing burden of storing large data. How often to erase raw data depends on the storage cost that manufacturer can afford. How to make our threat intelligence system more powerful? Let me introduce. After we have this filtered data, we can pass this cyber threat to product development department or other security vendors that can assist in defense. In order to facilitate the management of threat intelligence, it's recommended that it can be converted into a normal data format, such as sticks, ATT, and CK framework, to reduce the burden of threat intelligence exchanges between different manufacturers or units. This is a conceptual diagram of mutual defense. After we effectively manage cyber threat, we could form an IoT defense alliance through a uniform and standardized interface, as I mentioned before, with manufacturers in different fields and experts. An instant threat sharing platform can be created. All manufacturers participating in the cyber threat sharing platform can obtain the most effective cyber threat information for them and archive the best joint defense effect. For example, if the IP camera manufacturer finds a new web cyber threat, they can share this threat to NAS manufacturer, because the NAS manufacturer also uses similar web service on their product. Another example is a refrigerator manufacturer found some issue on their mobile app framework, and the NAS manufacturer and IP camera manufacturer use the same mobile app framework, so that the refrigerator manufacturer could share the mobile app cyber threat to both of them in order to protect each other. That's all for my talk. Thanks for your listening. See you at Hack in the Box Discord channel for questions and answers.